So let's try evaluating a linear system that ends up yielding a dependent set of equations. So let's give you the system 2x minus y equals 3 as the first equation, and then 4x minus 2y is equal to 6 as the second equation. Now what we want to do is we want to cancel out one of the variables. So let's say I pick y. So I want to make the coefficients of y in either equation additive inverses. So that way when we add both of the equations together, the y's will cancel out. So now note, if I multiply this top equation by minus 2, so if I multiply the whole equation by minus 2, the y coefficient is going to become plus 2y, which means that when we add it to the second equation, the y is going to give us 0. So let's do that. So the top equation we're going to multiply by negative 2, so this becomes minus 4x plus 2y is equal to minus 6. And then the bottom equation, it stays the same, we're not doing anything to it, so it's 4x minus 2y is equal to positive 6. Now when we add them together, the x's cancel out, the y's cancel out, and the constant terms cancel out. So we end up getting the equation 0 is equal to 0, which is known as a true statement. And when we have a system of equations that when we solve it, all the variables cancel out, and we're left with a true statement, we have what's known as dependent equations. So now we know that the system is dependent. And thus, since in a dependent system the lines of the graphs are basically the same line, we know that the system has infinitely many solutions. Now, how to express those solutions? There are two ways. There's the basic way where we know that y is in terms of x in a sense. So if we let's do some scrap work here. So if we let 2x minus y is equal to 3, well, we know, in other words, that y is equal to 2x minus 3, right? So one way we can write it is that the solution is all the ordered pairs which satisfy x, comma, 2x minus 3. What I basically did here is instead of y, I substituted for what we know y to be, which is in terms of x. And another way of writing it, which is more sophisticated, is the solution set is the set of ordered pairs x, comma, y such that either of the equations are satisfied. So you can say 2x minus y is equal to 3, or the set of ordered pairs x, comma, y such that 4x minus 2y is equal to 6. Now the second definition here is pretty advanced, and you need to know a little bit of mathematical notation, and in general what's required of you is doing this step.